me start recording as well. Fine. Okay. Can you see the slides? Please confirm in the chat box and then we'll quickly start. Okay. So let us start with this. So first let us quickly go through the questions of week 8 lecture session. So this is your first question. Answer it in the chat box and then I will discuss it. Okay, try to answer the questions quickly. So this is your first question. It states that for a polymer sample, elastic behavior is demonstrated at under which condition? Among the following conditions, which will be applicable for a polymer to show elastic behavior? Okay, so I am quickly moving through this question. So the correct answer was B, as answered by most of you, because you all know at high shear rate and low temperature, as the polymer chain does not have enough mobility, so they cannot cross each other, which is necessary for to show their viscous behavior. That means they cannot be viscous, so they cannot move past each other, so they will be showing elastic behavior under low temperature and high shear rate. Okay, so this is your second question. It is also very easy. For a Newtonian polymer melt, the shear stress is proportional to what of the following properties? For a Newtonian polymer melt, means it is your ideal one. The shear rate is proportional to which of these following things? I got one answer, that is shear strain. Another is, some answers are B. Okay, a bit of different answer in case of this. So far I have 3 answers that are saying B. Okay, so let me quickly state this. The correct answer is shear strain rate. I think those who have answered A, they have just confused the term, because if you look at the, one second, if you do look at the equation that the Newtonian fluid follows, then this is tau equals to eta into gamma dot, where your eta is your viscosity, tau is your shear stress, and gamma is your strain rate. Gamma dot is actually d gamma by dt. Do not confuse with it with the term gamma. Okay, gamma dot and gamma are different. Gamma is shear strain and gamma dot is the d gamma by dt. That means it is the rate at which the strain is changing. Okay, so the shear strain rate will be the correct answer. Okay, I hope there will be no more confusion regarding this. Just remember that gamma dot is d gamma by dt. Okay, it is a rate. So this was your question number 2. Quickly moving to question number 3. So this is the behavior a plastic sample shows under stress. It is your shear stress, and in the x-axis it is shear rate. So what kind of plastic is it? That is asked here. Okay, so many answers I am getting D, one answer A. Okay, you just need to remember the curve. Each of the behavior was shown in the one particular curve. Let me show it. Yes, the correct answer was D, and this was your stress versus shear rate curve. This is the ideal one, that is Newtonian, and which one have a what you can say intercept, that is Bingham plastic. So if anybody has any confusion, do remember that in case of Newtonian polymers, the straight line passes from the origin, because in that case the viscosity does not change when you increase the stress. Okay, so that is your Newtonian behavior. But in all other cases, because Newtonian and Bingham plastic is the trend is similar, both are straight line, but just remember, because Bingham plastic does not behave like a Newtonian fluid, so it will not be like a proper Newtonian fluid. The curve will not be same. The straight line does have a intercept. So whenever you see a intercept and a straight line, that means it is a Bingham plastic. And whenever there is no intercept, it is passing from the origin and a straight line, that means it's a Newtonian plastic. Okay. This is also very easy. You all will be the same thing. I have just shown it in the previous questions answer as well. So what kind of plastic behavior is this? Okay. Again, all of you have answered correctly. This one is pseudoplastic, or also known as shear thinning. I have not provided the curve for shear thickening. It is just opposite of shear thinning. It will be something like this. It will go around like this. Okay. It will be shear thickening. So for this one particularly, it will be pseudoplastic or shear thinning. Same thing. Whenever you are do not get confused between Cation plastic and pseudoplastic. Cation plastic has an intercept and pseudoplastic does not have one. It passes from the origin. Okay. So this is question number 5. It states, in a plot of viscosity versus number average molecular weight of a polymer sample, the slope changes sharply after a particular Mn value. This Mn value is known as what? What do you call this particular number average molecular weight? When the viscosity suddenly change beyond a particular molecular weight value. What do you call it? Okay, I have got one answer. Okay, so far I have got two answers, but both the answers are correct. The correct answer is entanglement. Why so? Because if you look at the curve where if you plot viscosity versus molecular weight, initially it behaves like a simple one where you increasing molecular weight and viscosity is increasing accordingly, and suddenly you do get a jump beyond a particular Mn value. Now the question is why this arises. If you take a real life example of this, like if you take two small hair strands or strings, then obviously they won't entangle between each other, right? If you take two small hair strands with each other, they will not entangle easily. But if you take longer hair strands, the much you increase its length, they will more try to entangle among themselves, right? This is the pictorial representation for this. Molecular weight increasing means you are also increasing the chain length of the polymer. So as you are increasing the length, they will have more and more tendency to get entangled with each other. And what does viscosity imply? Viscosity implies your movement is hampering. So more it's get entangled among each other, the chains, the fluidity of it or the mobility of it will decrease, obviously, because they cannot move past each other now that they are entangled with among themselves. So after a particular molecular weight, there will be sudden jump in the viscosity value, and we call this particular molecular weight as entanglement molecular weight. Okay. So this is question number 6. Okay, I will get back to question number 1 later. Okay, at the break time, before break time, I will show you the question number 1 again, whoever has requested. So this one also you all know. It states that damping ability of a polymer sample is measured by which of these following things that are given in the option. Very nicely, all have said the correct answer is D. Obviously, damping is a behavior for viscoelastic materials. It's basically where you lose the elastic behaviors and go towards like a solution like behavior. You start to behave like a solution rather than a elastic, or it becomes lesser and lesser elastic. So this is the damping process. So you do measure it by the ratio between G double prime divided by G prime, and you do know that G double prime is your elastic modulus or storage modulus, and your G prime is your viscous or loss modulus. Okay, So by their ratio we measure the damping ability of a polymer sample. Fine. Moving on to the next one, the optical property that relates to the reduction in resolution. Which of these following property relates to the reduction in resolution? Be very carefully the word resolution. I have 2 answers so far, 3, I think 4 answers. Okay, but they are kind of different. Because I know most of you will be confused between I thought most of you will be confused between A and B. Okay, I am getting different answers. Okay, so let us see the correct answer. The correct answer was clarity. I am not going to discuss or explain much in this question because I have a joint question. I have a similar question in question number 8. After discussing that, I will tell you why I have chosen, why clarity is the correct answer for this. Okay, first quickly do answer the next question, then I will discuss both the questions simultaneously. So for question number 7, clarity deals with your resolution. Okay, so this is your question number 8. Loss of contrast of a polymer sample can be quantified by the value of which of this property? I have one answer. Okay, two answers. It says loss of contrast. I have different answers. Okay, so the correct answer for this was haze. So let me explain that why the answers are coming this way. First, going back to question number 7, it states the optical property that relates with the resolution property. So first you have to know what does resolution mean. Okay, resolution means how finely you can identify the details within an object. It's not like how much shifted or something hazy it is. It's not like that. Resolution means any picture you are taking will have some finer details. Those finer details are called resolution. Okay, this is the basic difference. There is a difference between clarity and haze. Because you already know both the answers, now let me explain. In case of haze, it means I should have put the pictures that were in the slide. So haze mainly means you are not correctly identifying the outline of the things that you are seeing. Okay, something when you are saying it's hazy, that means you are not currently able to identify the outline of those things. Okay, then we call it hazy. We do not call it hazy whenever whenever you see a picture, suppose it is round, but let me show it like that. Suppose I have a sample like this. When you can see this, you can properly see this, you can see the outline and everything. You don't call it hazy in general. But suppose I know there are small holes in it. In this particular circle, there are small holes. But the picture is taken in such a way that the holes are not very clear to you. That means there is a problem in its resolution. Okay, because the resolution is not good, that means the amount of transmitted light that you are viewing it's not getting passed not getting passed through the sample or to the detector. So that means you are not able to identify the details that are within the object. That is called generally resolution. So that is dealt by a property called clarity. Okay, that is your resolution. And the next question was the loss of contrast. Okay, so if I go back to this example 1 again, loss of constant means if you have to see this same circle but you are seeing this somewhat like this, the lines you are not able to tell correctly. Why this is happening? This happens even in your real life as well. Whenever the weather is foggy or something, you say I cannot see, it is very hazy. Okay, although we do interchange the terms like it is not very clear or something, but the correct word is you mostly say that it is very hazy, I cannot see what are the things there. So what is haze? So whenever a light, suppose this is your sample, whenever the light is passing, okay, it is transmitted through this sample. Now if the lights get scattered, suppose you have placed your eye here, okay, now whenever the lights get scattered, it gets in different angle, okay, so only a certain percentage of it is getting to your eye, okay. So there is a certain angle that was also mentioned in your slide as well, when you will call it a haze. So some part of this light is getting scattered in other ways that you cannot see. So suppose one beam was getting here and getting past here, okay, it is getting diffracted in that direction. So due to this scattering, you are not able to get the lights that are scattered along this way. You can only see this part of this object. So the overall outline of this object that you are viewing, it is not very clear to you. That is called haze, okay. The definition of haze is percentage of transmitted light which is passing through the specimen that gets deviated from the incident beam, okay. So the incident beam was passing, but some amount of it was getting transmitted in different direction, so you cannot clearly identify what you are seeing, okay. If you go back to the slides that Professor Dhara has showed to you, then from the images that would have been better. I forgot to put the image here. So that is haze, that is loss of contrast, when you cannot see, cannot figure out the outlines that what things are there, that is called your haze, okay. Other two properties, I don't know why others answered A and D. They are completely different. I thought most of you will be confused between haze and clarity. So go back to these slides and look at those pictures that were given here. Then you can understand what is loss of contrast and what is loss of resolution. Okay. If you still have doubt, please tell me. I will mail you something again to explain it correctly. Okay. So this is your next question. What type of additive the following molecule is or are? This is your molecule. What type of molecule is it? Whether it is a cross-linking agent or a mold release agent or an anti-stat. I have one answer, two answer. Okay. That is very shocking. Okay, so most of you are answering cross-linking agent. That is very shocking. So, so far I have seen only two correct answers. So, correct answer was mold release agent. So, why people are taking this as cross-linking agent? Does that have any, can you see any group that can cross-link? This is a one molecule. You are putting this in your polymer molecules, right? So polymer molecules will have some functional groups. If it is a cross-linker, it should also have some functional group at its ends that can react with the polymers. Suppose it has a functional group like OH, suppose I am saying, and suppose at this molecule's end there is COOH. only in that case it could have acted as a cross-linker molecule. But look at this particular molecule. There are only CH3 groups at the ends. What can they react with? They cannot react with your polymer at all. So how can they act as a cross-linking agent? Do not get confused with this part. This is just the structure of the molecule that you are putting into. Cross-linking will be between this molecule and polymers if it was a cross-linker. These, do not confuse this particular part that it is take it as a cross-linker molecule, right? Because it does not have any functionality at its ends. So the correct answer was mold release agent. Why so? Because if you do look at the chains of it, what kind of molecule it is? It is nothing but a surfactant molecule. It has a long hydrophobic chain and a polar head group. So it is nothing but a surfactant molecule. So what can a surfactant molecule do? Suppose it is your mold. Okay. Thus in the previous lecture, week 7 lecture, you have learnt about molding. Okay. So suppose it is your mold, you are placing your polymer melt in it. So after it freezes or after it cools down, you will take the polymer from this mold. Now in case sometimes it can happen that it gets stick to the mold that you are using. So after it cools down, you are unable to take it out from the mold that you are using. So their surface are not going apart. They are attached to each other. So that will be difficult for you to remove the polymer or the polymer that you have made from the mold that you have used. Okay. So what can you do under this condition? We can put this kind of surface active agent or surfactant molecules. Their role is very clear from their name. They are surfactants, means they activate the surface. So if you have put this particular molecule in your mold, it will try to move to the surface. Okay, suppose it was your mold and there was a hole, and from which you are putting the polymer or melted polymer inside this mold. Now you have filled it up to that point and also added some of this particular surfactant. They will try to move to the surface of the mold, because that is what they do. They are surfactants molecule. They will prefer to stay at the surface of this mold. So whenever they will go to the surface, it will create a layer of surfactant molecules here. So there is a layer of surfactant molecules all around the mold. How will it help? Because of the presence of these surfactant molecules, now the polymer will not stick to the mold anymore, because there is a gap between them. Okay, obviously the surfactant that you have to choose in such a way that it does not react with mold, and obviously it will not react in general because they do not have many functionalities to react with in the first place. So they will not react either your polymer or the mold, and you know that these things are kind of viscous. So they will keep a layer in the mold that will be easier for you when you are removing the polymer after it has cooled down. So this is their whole purpose. Okay. So any kind of surfactant, if you see, they will act as your mold release agent. So this is your purpose whole. Okay. I hope it is clear. Same thing is written as here. So this is your question number 10. Which of the following parameters will increase the barrier property of a polymer sample towards gas molecules? Okay. There are 4 properties: higher free volume, higher tortuosity, higher crystallinity, and lower size of the gas molecules. Which of these parameters will increase the barrier property of a polymer sample? I have got 1 answer, 2, 3. Okay. What is tortuosity? Tortuosity, you can think something like this. Suppose this is your starting point. Many of you might not know tortuosity, so let me explain it again. So suppose it is your starting point and it is your ending point. So you can go via a straight line. You can obviously do that. Tortuosity is generally means when you do not go, if I explain it simply, if you do not take a straight line, instead you go through a linear pathways, you are ending at the same point but some curves you are getting through it. Okay, so you are just bending your path. Instead of getting it through a straight line, you are using some curvatures to go through from point 1 to 2. So that is tortuosity. Yes, yes. Someone has said hairpin curve. Okay. Now I think everyone can answer it correctly. That will be your higher, the correct option will be higher tortuosity and higher crystallinity. So the question was, which one of them will increase the barrier property? Okay. Barrier property means, so there is your polymer molecules. So there will be gap between the polymer molecules as well. Okay, I will once again request all of you to mute yourself, please. It is a bit confusing. It gets a bit confusing for me. One second. Okay, so let me get back to the question. So the correct answer was these two. As I was saying, barrier property means you are simply passing gas molecules through your polymer sample, and you can take it like how much the polymer is defending that action. Obviously, if you have enough space between polymer molecules, the gas molecules can get passed through. So the barrier property in that case will be less because it is not acting much as a barrier. But whenever you are like entangling the polymer molecules among themselves, or giving some fillers among themselves, or doing anything to decrease the pathway for the gas molecules, it will simply increase the barrier property. First, let us look at the first option, that is higher free volume. I kindly request all of you to please mute your audio. It is gets very confusing because all the sounds comes to me, right? Okay, fine. So first option is higher free volume. If you know the definition for free volume, it is basically, you can think free volume is the space between two polymer molecules, a space that is not occupied by polymer simply. So if this space increases, so the gas molecules will be it will be more easy for the gas molecules to pass through. So that means the barrier property will decrease. So the first option is not our correct answer because it has asked for increase in the barrier property. Now let us look at the higher tortuosity. Higher tortuosity means you have simply, suppose I am giving an example, suppose the polymer chains are entangled among themselves. You have increased the molecular weight so much, they are entangled among themselves. So now when the gas molecules has to pass through, it will have to go through a curvature like pathway. So that means higher tortuosity will increase your barrier property. Again, I am just explaining all these things as simple as possible. There are much more scientific terms. I am just trying to explain it as simple as I can. Next part is higher crystallinity. Again, if you think of crystallinity, so generally this is your amorphous parts of your polymers. In case of crystallinity, there are this type of domains, crystal domains, that are very much well arranged among themselves. So whenever they are very densely packed among themselves, that's why these crystalline domains are forming. So whenever a gas molecule has to pass, it can pass through the free volume between the amorphous polymer region, but whenever it will go to this high denser crystal regions, it will get hampered. It cannot pass further because these crystalline domains are much more denser and much more ordered, so it will not have much space to move through them. So higher crystallinity will obviously increase the barrier property of a polymer. Next is lower size of the gas molecules. Obviously the lower the size of the gas molecule, it will be easier for them to pass through any kind of channel. There will be much less barrier for them. So this answer is also not correct because lower size of gas molecule will generally decrease the barrier property. So according to the question, the correct options were B and C. Moving to the next one, this one also all of you know. Brominated aromatics work as fire retardants by which of these following mechanism? Okay, I think you all know this. So the correct answer from this is interfering with the chemical reactions in the fire. You already know this because there are mainly three mechanisms. Either it can form, either it can form an insulating charge, or it can form some interfering chemical reactions that will help to maintain the fire, or it can release water at high temperature by some other mechanism. So brominated aromatics obviously works as by interfering with the chemical reaction that happens within the fire. This question is again all of you must know, I think. Phosphorus flame retardants work as fire retardants by which of these following mechanism? You also know this, I know. This is just straight from the slides of your class, so all of you know it. Okay, it's already 7:38, so let me quickly move to it. So the correct answer for it, that phosphorus flame retardants works by forming an insulating charge on the substrate. So those who did not get the correct answer, try to remember the example that were given in the slides for all this kind of fire mechanism, because that will be important for your exams as well. Do try to remember all the examples that are given alongside the mechanisms of fire retardants. Okay, this is your question 13. Of the following polymers which are biodegradable? This is also straight from your slides, the slides from your classes. Quickly just try to remember. Yes, I have already got the correct answer. So the correct answer is A and B. So these are the structures, those polymers that were biodegradable. These two are obviously not biodegradable. This is polystyrene, and both of these are used commercially in the industry for making different plastic materials and everything. So obviously they are not biodegradable, you all know already. So A and B were your biodegradable polymers. Okay, these are given in your slides, so I am not wasting much time in it. This is your next question. Which of the following factors lower polymer miscibility? Which of these following factors will decrease the miscibility between two polymers? I have two answers, three. Okay, today everyone is giving correct answer. It's making me happy. Okay, so the correct answer is A. So whenever you increase the molecular weight of the polymers, the miscibility between them will decrease. It is very obvious as well, because increasing polymer molecule, any kind of process, it is directed by your delta G ultimately. If it has to be miscible, two polymer has to be miscible, then the delta G value has to be negative, obviously. Now delta G is composed of two terms you already know, that is delta H and your delta S terms. So whenever you increase a polymer's molecular weight, it is basically you are increasing its size. The larger it gets, the lesser its entropy will be, because it is difficult for a larger molecule to move, right? So the entropy will decrease, and you know that ultimately your delta G have to be negative. So from this equation you can obviously tell, if your delta S is highly positive, then this negative term will be beneficial for you. But as you are increasing molecular weight, you are actually decreasing the contribution or a positive contribution that is coming from delta S, because it will be difficult for larger molecules to move around. Okay, so obviously that will lead to less negative delta G value, so your polymer miscibility will decrease. And coming to the other points, that is hydrogen bonding, ionic interaction, or electron donor acceptor complex formation, these all are some kind of interaction between polymers. Some kind of bond formations are present in each of these, or some non-covalent interactions like ionic interactions are also present. So all these things, whenever this kind of interactions takes place, it gets a, or it contributes a negative delta H value whenever there is some kind of interaction between two polymers, some bond formation or any interaction like this complex donor acceptor complex or ionic interaction. So there will be a negative contribution from enthalpy value. So as delta H will be more and more negative for all these case, so it will be good for you, because ultimately you want delta G negative, and if delta H is getting negative value, so that is obviously good for you. So these all things will facilitate polymer miscibility. Okay, so only the first one, increasing molecular weight, will decrease the polymer miscibility. Moving to the next question. Okay, the morphology of a blend of two amorphous polymer. The morphology, it is given here, polymer A and polymer B. Here is the picture. Which of the following should increase the transparency of this sample? So this is the blend polymer A and polymer B. This is their morphology. Which of these following parameters will increase the transparency of the sample? Be very careful about this particular term, transparency. Okay, I have two answers, A and C. Another is A only C. Okay, three answers so far. They have one answers in common but slightly different. Three answers I have got, and most of are saying A and another is C. These two options are saying. Okay, increase in the size of polymer A domains. Okay, I have got one answer D. Be careful with this term, transparency. Okay, as we have to go to the numerical problems again, let me quickly explain this question. Okay. Oh, fine. So it states which of this will increase the transparency. So what does transparency means? Transparency means that incident, suppose it is your material, you have your incident beam and this is your transmitted light. The more light will be transmitted directly without getting refracted, scattered, absorbed, anything. Okay, the less this molecule will absorb or scatter or refract, the more will be transmitted easily from this sample. So higher the transmitted light, I mean if the intensity of it is I0, suppose it is I, the transmitted light's intensity, the closer the value of I is to I0, the more your material gets transparent. Means whichever light is passing through the material is getting transmitted. Okay, so that is your transparency. So let us see which of these things can increase the transparency. First is decrease in difference in the refractive index. Obviously this has to be, because whenever you are using a blend, suppose it is like that, I'm just taking two sections. Suppose it is your polymer A. Oh, sorry, one second. So it is your polymer A phase, these green ones, and this gray area is your polymer B phase, that is shown here. Now whenever a light falls on it, it can transmit like this, or depending upon the refractive index of this particular material, it can refract at different directions. Okay. Now if these two polymers have too much difference in their refractive index, that means what will happen? Suppose this green one will refract all the lines along this angle. This is your incident beam and it is refracting all the lines along this direction. But your gray part or polymer B part is refracting your light along this direction. Okay, so there is a huge difference between the refractive index. So that means ultimately a very few percentage of light you will get transmitted from your system. You will not be able to see the whole light that you initially placed in front of the object. So you are placing I0 here, but whenever you are looking from this side, you are suppose only seeing I0 minus certain fraction of light. So you are not getting it because their refracting index is so different. The light is constantly refracted in different direction and not getting transmitted properly. So obviously decrease in the difference, if the refracting index are too high, so the transmittance will be less. So decreasing the difference will be highly beneficial for us. So try to always keep their refracting index value, that is eta values, as much close as possible to get highest transparency. So our option A was correct. So obviously if option A is correct, we can reject option B. Now coming to option C, that is decrease in the size of polymer A domains. So even if their refractive index are close to each other, but ultimately they are different. So you can think these green dots are actually a kind of impurity among this large gray box. Okay, so suppose this gray box here material, and you can think these green dots are actually impurities that are present in your sample. So the light that could have been passed through this gray material is somewhat getting absorbed or refracted or scattered by these green dots. So if you do decrease the amount of the polymer A domains, that means you are actually dealing with a much purer sample of polymer B, obviously. So that means there will be much less interference from those green dots or the impurities. So obviously that will lead to the increase of the transparency, because the green dots are present in small amounts. You can obviously see that. So if you can remove them, so you are actually getting close to a more pure substance, that is a more pure refracting index or a single refracting index. So that will lead to higher transparency as well. So decrease in the size of polymer A domains will also help us in getting a better transparency of the overall object. So option C is correct, and so we can reject option D accordingly. Moving to the next question. A blend of polymer A and B is found to give two Tg values. One is 140 degree centigrade. One is 140 degree centigrade and another is 112 degree centigrade. Okay, so this is the Tg values you are getting for the blend of these polymers. Now For individual polymers, for polymer A, Tg was 150 and for polymer B, Tg was 100 degree centigrade when they were individual. Whenever you are mixing, you are getting two Tg values, that is 140 and 112. Okay. So now they are asking, are the polymers completely miscible or immiscible or partially miscible? That is your question. Option 4 quite doesn't make any sense. So because they have to, otherwise they can be miscible, immiscible or partially miscible or partially immiscible basically. One second. So the answers that I am getting are C, another one saying B, another one is saying C. Okay, most of the answers are C. C, fine. Okay. So again, most of you have answered it correctly. So for polymer A, it was 150 individually. Let me write it down. And polymer B, it has a Tg value of 100 degree centigrade individually. Now you have mixed them. So coming to the first option, if they are completely miscible, then after mixing we would not get these two different Tg values, because if they have mixed completely we will only get a single Tg value. So obviously our first option is not correct because we are getting two Tg values even after mixing. So our first option is wrong. Coming to the next option, completely immiscible. If these two polymers are completely immiscible, that means they are not reacting with each other at all, then we would have get same Tg values as their individual ones even after mixing, because they haven't reacted with each other. So the value 150 and 100 will remain. Even after mixing they will remain same if they are not miscible at all. But we can see that the Tg values has changed to some extent, like approximately by 10 degree they have changed. So we cannot say that they are completely immiscible. We cannot say that because they have changed. Now coming to the third point, this is our only possible option, that they have miscible to some extent. Because of that, the 150 value has come down to 140 and 100 value comes to 112 because of mixing among each other. So the correct action should be partially miscible. Okay. Moving to the next one. Which of the following properties get improved over base polymer on addition of nano fillers? So you are actually adding nano fillers to your polymer. Which of these properties will be improved by adding nano fillers? I am getting A and B. Okay. Very good. Again, everybody has answered the correct thing. That is heat distortion temperature and barrier properties. So nano fillers mean you basically put something like this arranged crystalline domains or nano clays in between the polymers. So whenever you are adding this kind of fillers, you are basically increasing the free volume between them. So obviously that would lead to the heat distortion temperature, because it can now handle more stress than it could have handled earlier, because you have added these fillers in between the polymer chains. So its capacity to handle stress has increased. So the heat distortion temperature will also increase. That means this property will improve. Next is barrier properties. Obviously Barrier properties, as you are increasing, adding these nano fillers, you are increasing the space between these polymers that were existing. So that means there are more space. So the more freely the gas molecules will be able to pass. So are improving the barrier property of the polymer. Obviously, the ductility won't be increased, because ductility basically means uh, elongation at break, right? So in introducing these crystalline like domains will impose more of a glass like structure. Okay, not fully glass, I'm just stating introducing these crystalline domains means you are basically introducing more glass like structure. That means it will lose its some kind of elastic behavior. So obviously the elongation at break, that is ductility, cannot improve after this point. So this property would not be improved if you add nanofillers. Now coming to transparency again, if you look at these nanofillers as crystalline domains, then what will they do? They will scatter the light much more, and obviously because they are much dense, so lesser light will be passed through them. So their transparency or the transmitted light will be decreased after passing through them. So obviously you will get less transparent material. So the fourth point is also down. Fine, this is done. Okay, I think this was the up to question 17. So please let me know if you guys need some break or not. If not, then I will continue. Otherwise, I will start with the numerical problems. It depends on you. As it is the last class, so I am asking. Please tell me whether you need breaks or not. Then I will provide you 5 minutes break. Otherwise, I will immediately go to the numerical question. Okay. So let us go to the numerical question. So I can expect that you all have read, because you have your exams in 24. So you all have gone through all the slides. So you all will be able to answer them. Negative marking. No, there is no negative marking in the exam. There is no negative marks. Okay. So this is your first numerical problem. It states, find the average degree of polymerization for the following polymer with an average molecular weight of 1 lakh. This is your first question. Try to do the maths quickly. You can take it as a mock test as well, because you won't get much time in your exams as well. So try to calculate as quickly as possible. Find the average degree of polymerization value for this particular polymer with an average molecular weight of 1 lakh. How much question? There will be, I think, 50 questions. I think, yeah, 50 questions. You have 100 marks, 100, the exam will be for 100 marks, so there will be 50 questions, yes. For exam center exchange, I cannot help with that particularly. You all also get an email from NPTEL IIT Madras team. There is a group, so you can mail them, because these technical things they can answer. We don't handle these things. Okay, I have got the first answer. Subjective question in sentence. There will be both similar like assignments. There will be memory based question, subjective question, numerical problems. I mean, not everything will be MCQ or MSQ. Not like you have to write down any answer. I mean long answer. But there will be memory based question, normal numericals, MSQs, everything, just like your assignment. Yeah, it is provided in the slide as well. The questions that I am showing here will be very helpful in your exams as well. So try to solve this question. This will be very helpful for you. Okay, so I have got some answers. 877 most people are getting, around 877. There will be 2 marks question. Okay. 877. One has got 797. Okay. So let us look at the answer for this. 877. Either I have done something wrong in this decimal while calculating or something. Let me calculate it once again. I think I have, oh, I have put less 0 in here. Okay, so those who have given the answer 877 actually are correct. I have just put a less 0 in here. So uh, if you look at this polymer, it is basically a ring open polymer of this particular molecule. It is a ring opening polymerization. That means a single monomer is involved in this case. It is not a condensation polymerization between two polymers. Okay, so it is simply a ring opening polymerization. So as only one polymer monomer is involved, so obviously our degree of polymerization will be equal to n or equal to the number of repeating units. So in this case, our dp will be what? You can see 1 lakh was your molecular weight of the polymer. You can just calculate the molecular weight of the repeating unit, that will come around 114. So to get the number of repeating units, you just need to divide molecular weight of the polymer divided by molecular weight of the repeating units. So 1 lakh divided by 114 will be 87.7. Yes, I have seen it. I just put 10 less. That's why the correct answer should be 877. I have just during calculation here I have put 1 less 0. Okay. So moving to the next one. This is your next question. The number of structural units and repeating units for the following polymer with a molecular weight of 1 lakh. You have to both calculate the structural units and repeating units. Use of calculator. See, we have mailed them and called them as well, but we did not get any reply regarding that, so I cannot help with that. But we have confirmed that yes, we have asked that there will be e to the power 10 to the power these functions available, so that won't be a big problem for you. But we have asked them that whether you will be provided with some additional practice session with the calculator, but we haven't get any reply yet, so we can't help with that. So basically it's if I tell you, it's simply different. Like whenever you use in your calculator, you are writing like something, how to say it, like e to the power, you first place e to the power and then write the number. In case of general calculator, it is just opposite to that. You first put the numbers and then select the function that you want to operate. It is just slightly different in that case. First you have to place the number there, and if you then press the function, the calculator will show you the result, as far as I remember. Okay, so still, because I haven't used it personally, I cannot fully confirm it, but that is how all the online calculators work for all the exams. So on that basis I am just saying. No, the model paper won't be provided because I am not instructed to do anything like that. So the team has given us clear instruction that is not included. So far I have got only one answer. I am answering your queries in the chat box, but meanwhile you all please calculate the problem or solve the problem as well. Another answer is C. Others also please try. We have many numerical problems, so please try to do it a bit quickly. At least one more answer, and then I will show you the correct answer and how to solve it. So far I have just got two answers, and both of them are different, so I want at least one more answer so that I can show you the answer of this question. C. Okay, so the correct answer was C, because again if you look at the polymer, so it is nothing but made of a single monomer, right? So the monomer is simply this double bond was polymerized and you got your polymer. So the vinyl acetate was your single monomer that was used to synthesize this polymer. So whenever only a single monomer is used, I have said this to all of you multiple times, you just need to remember single monomer means dp will be equals to n. dp equals to n, where n is your number of repeating units and degree of polymerization will be is your structural units, so number of structural units. So obviously number of repeating units and degree of polymerization or structural units are same in this case. So simply you have to calculate n. So if you first calculate the molecular weight of this repeating unit, so that will come around 86. So you just need to divide the molecular weight by 86. That will give you the number of repeating units as 116. As in this case your structural units and repeating units are same, so your structural units will also be 116. So the correct answer was 116. Okay. Next, this is the next question. The functionality of the following monomers during polyamidation reaction with hexamethylene diamine is. These are the monomers. What will be their functionality while polyamidation reaction with hexamethylene diamine? Exam hall ticket not received. Okay, so see, I don't actually deal with this kind of technical things or exams at all, right? So there is another group that we all are there, okay, that is where NPTEL IIT Madras team who sent you the notifications for exams and everything, like the questions, the answers, everything, they even the re-evaluation they have mailed you, right? So that is the actual core team, technical team who handles this or all these exams and admit cards and everything handled by them. So you can just write a mail to them, because I will not be able to help in this case. I can only contact to our professor, and he also does not he will also not be able to say this, because he does not also handle this kind of things. So please, whoever is having any technical issues regarding this upcoming exam, write to the team directly. I think they will answer your query. So the correct answer, so everybody got it right. So it was your first answer A, 2 and A, because hexamethylene diamine means simply it is your CH2 whole 6. Let me not write the whole structure. It will be CH2 whole 6, and in the both side there will be NH2. So this is your one NH2. There will be another NH2. So obviously In case of the first one, it has two COOH group that can react with hexamethylene diamine, so the functionality will be 2. In this case, there is only one COOH group that can react with this NH2 group to form amide bond, so your functionality would be 1. Moving to the next one. The following polymer was synthesized from terephthalic acid and ethylene glycol by step growth polymerization. Okay, so it is made of terephthalic acid and ethylene glycol. The weight average molecular weight of the polymer with the average degree of polymerization 450 is. So you have to calculate the MW. You have to calculate the MW, and the degree of polymerization is given as 450. Okay, 450 is given, the structure is given, you have to calculate the MW or the weight average molecular weight of this particular polymer. Yes, in some cases it can happen that the structures are not provided, like citric acid or suppose this hexamethylene diamine, as these things are so many times discussed within the lectures, so those structures might not be provided in your exams as well. Those things that are frequently discussed, the structure that are discussed in your classes, so that might not be available during your exam. I do not exactly know, that might not be available, or because it's a exam, so it can, but citric acid is a simple one, like at least if you do not remember the whole structure, you can remember that how many acid groups are there, that is all. I got one answer, two answer, but they are different. I have got one answer. Again, if you are asking a question from current assignment, please do not ask the question in the session. I have told this multiple times, I cannot give you the answers of your ongoing assignment, so please do not ask such question. I have got two answers, a bit of problem with 0. One answer is 43200 and another answer is 4320. So bit of like somewhere someone might have missed a 10 or multiplied a 10, something I have to see. So I have got two answer, one more answer at least, and then I can show you the correct answer for this question. 43200. Okay, so 43200, fine. Okay, fine. So 43200 will be answer. One more answer at least. Two of them have given the answers, and most of the time they answer all the questions, so others please try. I do know they, because they most of the time these people answer the question, and most of the time they answer correctly, so others also please try. At least one more answer quickly. Okay, as I'm not getting any more response, let me show the answers so that those who are answering, they can at least solve as much numerical as possible. So the correct answer was 43200. Both of you are correct. So this was again a very easy problem to solve. See, the question state the polymer is made of terephthalic acid and ethylene glycol. So now we know that the polymer is composed of two different monomers. So whenever the polymer is composed of two different monomers, the first thing that you have to write down is the degree of polymerization is 2n. Single monomer means dp will be equals to n. Two monomers mean dp equals to 2n, where n is your repeating units. So in the question, let us see what is given to us. The degree of polymerization value is given to us. So basically dp value is provided to us. So we know our dp value is 450. That is equals to 2n. So from this we can easily calculate the value for n. That is the number of repeating units that are present there. So let us see. The number of repeating units was 225. Simply divide 450 by 2. So your number of repeat units is 225. So we know there are 225 number of these repeating units. Now you just need to calculate the molecular weight. So see, this is your repeating unit. First calculate the molecular weight for this particular repeating unit, and this repeating unit is present 225 times. So obviously you just multiply them to get the overall polymer molecular weight. So first you need to calculate the molecular weight of the repeating unit. It will come around 192. Okay. So this kind of units are present 225 times. So what will be the molecular weight? 192 into 225. So that will give you 43200. And obviously it was mentioned that you need to ignore the contribution from n groups. So it was 43200. In case if it, in your exam the n groups are provided and it is told that you have to take account of the n groups as well, then just add it. Okay. In case suppose it is written here as OH and here it is written as H, and it states that you also have to consider the molecular of the n groups. In that case you just need to add the molecular of the n groups, that is OH plus H means equivalent to water's molecular weight, that you just need to add 80. Okay. In that case, explain once more. Okay, so let me tell this very clearly. This will be obviously this kind of problems will this similar numerical will appear in your exam. Okay, so this states it is the polymer is made of terephthalic acid and ethylene glycol, and whenever we see the polymer is made of two different monomer, we can surely write dp is equals to 2n. Okay, because it is made of two different monomer. And in the question the value for degree of polymerization or dp is given as 450. So 450 equals to 2n. So from that we can get the value for n is 225. So now we know that there are 225 repeating units like that. So this was your n repeating units. So there are 225 repeating units. So now just we need to calculate what is the molecular weight of our repeating unit. If we calculate, it will come around like 192. So the molecular weight of individual repeating unit is 192, and there are 225 such repeating units. So that will give you a molecular weight of 43200. So this is your next question. Consider an external acid catalyzed polymerization of an equimolar mixture of diol and diacid. The time that was needed to reach 99% conversion was 300 minutes. Calculate the time required to increase the conversion from 99 to 99.5. Okay. So the time required to reach 99% conversion is given. How much time will be required to increase it to 99.5%? The assumption is also mentioned, so you don't need to worry about that. Again, a very simple question. You have done this in your assignment as well and in the doubt session as well. Once you are done, write down the answer in the chat box. Okay, so I have got one answer. As we have multiple problems, so let me show the answer as well. So yes, you were correct. The correct answer was 303. So we do know what kinetics does. A step growth polymerization follows. 1 second. Okay. So this is our equation. Xn is equal to 1 by 1 minus p, which we can write as 1 plus C0 kt. The whole derivation is there in your slides, as well as I have discussed in the live session as well. So this particular equation, I have mentioned this also, that you do need to remember this equation. Even if you do not remember the whole that how to derive this equation, but you do need to remember the end equation. So this is your equation. 1 by 1 minus p is equals to your 1 plus C0 kt, where p is your percentage of conversion, okay, and t is your time, that you also know. So the only unknown things are C0 and K, that is your initial concentration, and K is your rate constant. These two things you don't know, but in the question it is mentioned that for 99% conversion, the time required was 300 minutes. So we do know the value for T and the value for the percentage of conversion. So it was 99%. So in place of percentage of conversion, we can write 0.99 because it was mentioned 99%. And also you know T was 300 minutes. For 99% conversion, time required is 300 minutes. So when you place this, you can calculate C0 K value. Now it is mentioned in your question to assume that the rate does not change throughout the polymerization reaction. So see, C0 is constant. C0 is your initial concentration. So that won't be changed. So we can take that as constant. Now again in your question it is mentioned to take K as constant as well, because it does not change throughout the reaction. So this C0K will be same whenever you measure. Even it is 99% conversion or 99.5 or full conversion, anywhere the C0K values are constant because they are not changing. So whenever you get the C0K value for 99% conversion, that will be same for your 99.5% as well. Okay. So you just need to calculate initially one value for C0K. Once you get there, that is your fixed value for throughout the reaction. Now let us go back. Now they have asked that you are increasing the conversion from 99% to 99.5%. Okay. So let us see how much time does that require to reach 99.5%. Again, we know the p value, that is percentage of conversion, is 0.995. So we can put it there. 99.5% means 0.995. Okay. Fine. 0.995. We have put that. We also do know the value for C0K, that is 0.33 minute inverse. Once we have put all the values, we can get the time that is required for to reach the 99.5% conversion. Everyone, please mute yourself. This is by request. I am requesting multiple times. I am muting many people, so please stay in that way. Okay. See, this breaks the whole connection. Okay, fine. So the time that is required to reach 99.5% is 603 minutes. So the question that was asked, that how much time is required to reach 99 to 99.5. So T99 means this is the time required from initial reaction to reach 99%, that is 0% to 99%. And T99.5 means this is the time required to reach from 0% to 99.5%. Okay. Now the question asks, what is the time required to reach 99 to 99.5? So obviously we just need to subtract those two values to get our answer. So the correct answer should be 603 minus 300 minute, that is 303 minute. Okay. So please do remember how to solve this question. You just need to get the value for C0K using the value for T and P that are provided. Once you know C0K, that is fixed for throughout the reaction, you put the same C0K value for the other part of the question that is asked. You know the percentage of conversion, you put there. You have the C0K value, you put there. You get your time required for the particular percentage of conversion. Okay. And please do remember this equation to solve all the questions like this. Moving to the next question. This is your next question. The amount of benzoic acid should be added with a mixture of 1 mole adipic acid and 1 mole ethylene glycol to produce a polymer of Mn value 12,000 at 99.5% conversion. So amount of benzoic acid means you are basically wants to stop the reaction. You are adding a chain stopper from outside. What moles of this chain stopper will be required to get a Mn value of 12,000 at 99.5% conversion, and this is the structure for your polymer that is also provided. Exam total marks is 100 and pass marks I do not remember. I think that instruction was provided. I think something around 40% or something. I do not clearly remember the passing marks. The full marks is 100. I cannot send the hall ticket. I am not the in charge for exams and thing. I do only have the duty to teach you all, take the live sessions, make the assignment questions, solve the assignment questions, and etc. I cannot do anything technical. That is all handled by IIT Madras. If you have any query, write to them. Go to this conversation. Go to that group that from where you got every mail about your assignments, re-evaluation, exam center, everything. Go there, mail them. They will be able to answer them. Okay, I do not have the answers anything regarding the exam centers or those things, or admit anything. One. Acha. Okay. 1 moles. Acha. Fine. Sorry, I did not get it. Okay. I've got one answer. It is stating 1 mole. Quickly, at least 2 answers, and then I will show you the answer and how to solve it. See, you all have solved similar question in assignments. So you all should actually be able to solve these questions as well, because similar questions were in your assignments and your live session as well. And 24 is your exam. So I can hope that you all have read already or started reading already. Assignment 1 and assignment 4. Can you please tell me the questions that you have a problem with? Or you can you can send a mail as well. If there are any question left that needs re-evaluation, then with proper reason send an email. Okay, we still have time to re-evaluate the assignments and everything. So by today is 19, so by tomorrow, by tomorrow midnight, if any of you have any problem regarding re-evaluation, some questions that hasn't re-evaluated yet, please send an email. We still have time to re-evaluate the assignment, so we will go with it. We'll collect all the queries and then we can ask them to re-evaluate. Okay, mention the assignment number, question number, and what is the issue. ক্লাসে এসে পরে ফোন করবো না already gave email. See, the emails that we have got, all the necessary questions that we thought needs re-evaluation, we have sent it to the IIT Madras team, and as a result you already saw that many of them were re-evaluated. Even you all got an email regarding this. If even after that some questions are left that needs re-evaluation, please send the mails again, because there are so many mails, right? We have collected all of them and sent them, yet send another email. By tomorrow midnight I will go and check them and make a list. If any of those questions still requires re-evaluation, I can still send an email to that IIT Madras team, So do that quickly by tomorrow midnight. Okay, we still have time. So any query you have to mention assignment number, question, and what is the problem in that. It is for is it for everybody, or it is your some personalized personal problem, like you have written an answer, the range is not matching, something like that. Mention the reason also. Okay. Okay, so far one answer was 1, another answer was 0.99. Unfortunately, I don't see any of the answers matching. So again, let me tell you what should be the correct way to solve this problem. I will get back to the chat questions later. First, let me solve this, explain this question. I will again get back to your queries. Okay. So first of all, what is provided here? The total molecular weight is given, that is 12,000. Fine, we have that, and we do know the molecular weight of the repeating unit. We can calculate it as the structure is provided. We can calculate the molecular weight of the repeating units, that is M0. So if we do know the overall molecular weight and the molecular weight of the repeating unit, then just by dividing them we can get the value for N, right? So that is what is done here. Your degree of polymerization value is given as 12,000 divided by 172. 172 was, I think, what is the molecular weight of this? Okay, first of all, another things you have to consider, the polymer was made of adipic acid and ethylene glycol again, so it is two different monomers. So you have to calculate, this will give you the dp value. Degree of polymerization will be 2n, so you do need to calculate it. Let me quickly calculate this thing once again. I will put the calculator. Let me calculate the molecular weight of this particular repeating unit as well. So it is coming as 172. Yes, 172. I was taking the both the sides of H and OH. It should have been mentioned that to ignore the contribution from the N groups as well. I was calculating and I was getting 190. So yes, it should be 172. So now we have our xn value, that is 12,000 divided by 172, that will give you a value for 69.77. So first of all you need to divide the molecular weight that you are provided with the repeating the molecular weight of the repeating unit. So you will end up with 69.77. Fine. After that, what you need to do, it has stated there are 1 mole of ethylene glycol and adipic acid, I think. So Na and Nb both are 1, that is you know. Then you need to calculate, consider this equation, that is xn equals to 1 plus r divided by 1 plus r minus 2rp, where r is the actually ratio of the additives that you are adding and the moles of your polymer. So I will get back to that later. First, let us consider this equation, xn is equal to 1 plus r divided by 1 plus r minus 2rp. So if you rearrange this equation a bit, you will end up with this particular equation. So for mathematical purpose, you will only need this equation. So for your exam purpose, try to directly remember this equation. Instead of rearranging and doing everything, for your exam purpose, this similar kind of problems will come, right? So you will have to use this equation. Try to directly remember this one. Now you have your value for xn. Also the percentage of conversion was also given. It was 99.5. That was also given in your question. So you both know the xn value and the p value. So the r will be 0.9814. I think up to that each of you calculated correctly. Someone said 0.99 or something like that. But it has asked that how much amount of benzoic acid you have to add to stop the polymerization reaction at 12,000 molecular weight. So then we have to get back to this stoichiometric ratio. Without any additive or chain stopper, generally without any chain stopper, the stoichiometric ratio is generally written as Na by Nb when you do not add any kind of chain stopper. Whichever is highest, whichever mole is greater, that goes to the down, so the R values is always less than 1 whenever you are not using any chain stopper. But when you do use any chain stopper, you have to consider the moles of it in the stoichiometric ratio as well. So you need to add another term that is written as 2Nb prime. So this was your confusion for many people. So why do you require 2 in case of this? Why 2 is placed in front of Nb prime? This is because, so this is suppose your adipic acid and the reaction was between adipic acid and ethylene glycol. Okay, fine. So suppose your adipic acid has a COOH functionality. This is reacting with ethylene glycol. Ethylene glycol means CH2CH2OH. This is your overall reaction that is going on. Now you are adding a chain stopper. Okay, you are fixing the particular molecular weight. So whenever the reaction, suppose the reaction was going well, fine. So you have added a chain stopper here, COO. Here is your ethylene glycol molecule. Okay, I am just writing. Here was your ethylene glycol molecule. Now as a chain stopper, you have added one benzoic acid. Okay, so benzoic acid have one COOH group only, right? It has only one COOH group. What it can do? It can simply react with this ongoing ethylene glycol chain, and once it reacts with that, it will form a ester bond here, and at the end you will have your phenyl group. So this end of this polymer cannot propagate further because you have stopped it with benzoic acid. But still remember that other side of the polymer chain is still free. Okay, so in that side the reaction is still ongoing. That means if there is another COOH group of this adipic acid, that can still react with ethylene glycol and keep on the reaction going. So to stop that, you cannot just put benzoic acid to one end of the polymer. You have to stop both ends of the polymer to fully stop the polymerization process. So whenever here is also another ethylene glycol standing and reacting continuously. So to stop the overall reaction, you have to add another mole of COOH group or the chain stopper, that is benzoic acid, to this side of the polymer as well, so that both the sides of the polymer chain stops growing and you get your fixed polymer molecular weight. So that is why the 2 is always added before Nb prime. That is, Nb prime actually is the moles of number of moles of chain stopper that you are using. Now in the question multiple time you have asked what we have to get, whether we have to write the value that we are getting for Nb prime or whether we have to report the value that we are getting from 2Nb prime. So see, Nb prime is the number of moles of benzoic acid that you require with respect to your Na and Nb. Fine. But in the question it is always asked that how much moles you do require to stop the reaction. Every time it is asked. So obviously just I have explained, you cannot stop the equation with a ratio of 1:1. If the monomer ratios are 1:1, always you need a 1:2 ratio so that they both react with the two ends and stop the reaction. So always the ratio will be, or the moles will be twice than the monomers moles number. Okay. So the ultimate answer that the question always asks is the value for 2 Nb prime. Nb prime is the number of moles of benzoic acids, and 2 Nb prime is the number that will require to stop the reaction at a particular molecular weight. So in the exams as well, the value that you have to get is the value for 2 Nb prime. Okay, not the value for Nb prime. I hope now it is clear why the 2 is incorporated in the equation and why you need to report 2 Nb prime instead of Nb prime. Okay, so be sure with that. That is, one second, degree. This is one thing that I have wrote here, na. This should not be xn, this should be actually the number of repeating units that you are giving. You are right, I was actually confused because of that. I wrote this, then I thought that whether 172, if it is the molecular weight, then we should divide it by 2 to get it the value for, I mean degree of polymerization should be 2, and that's why I recalculate the whole thing. So it is basically you have to calculate the value for n, that is you need to calculate. I mistakenly wrote that at xn and that's why I got confused. Okay, so obviously the dp value should be 2n, that's why I recalculated everything. So this is nothing but the equation that is mentioned here, na? This is all will be, that is talking about the number of repeating units throughout. This is one problem that I did. If there is any problem regarding this, because it's a bit confusing, I will once again check it. If I have mistakenly placed anything here xn or n or the calculation, I will recheck once again. Okay, because I am also getting a bit confused about why this is 172 is placed here as well. So I am also a bit confused because it should not be. Yes, that should be the thing. Yes, that's why I am also bit getting a bit confused that why in the solution it is not stated as this, because this is also a previous year question. So this is not mentioned here, so let me check it. Okay, I will tell you in the mails as well, because I also do have this doubt. Okay, so otherwise understand the rest of the things that you have to understand this 2 Nb prime. The other things I will explain, the xn and n thing. Okay, sure. I will mail everyone regarding, I post a message in the group. Okay. Next, this is your question. A mixture of 10 moles of glycerol and 10 moles of succinic anhydride. Determine the extent of reaction at which gelation will occur. Now see, in this case, both the structure of glycerol and succinic anhydride is provided, so you do not need to worry. In exams, it might be provided as well. So both are of 10 moles, they are reacting with each other. What is the extent of reaction where gelation will occur? Shanti Kumar. Okay, so as far as I know, one question was evaluated. I mean, so one question was not given, considered wrong because the bracket was not given. I know we have also forwarded this issue. I think still they haven't responded to this question. So yes, we also know, we have talked to the professor as well, that this particular problem is still not acknowledged. We have told them that this should be re-evaluated. If there is any question in assignment 2, you can email me, but I think I do remember the problem with assignment 4 question or something, where whoever put Roman 1, 2, 3, they did not get the answer. Only if you put a bracket, then you got the answer. I do remember that. We have talked to them, asked them over phone as well. Hope they will soon answer our question. Yes, I have said this is the same question in the revaluation thing will be the marks should be provided to all. See, you are saying me this, I have actually mailed them all these problems. Every time you say that this problem is happening, you are not getting marks due to a wrong question, I have talked to them even personally that what could be done with this question, because the question was itself wrong and the answer was also wrong. They said that they have to either omit the question or re-evaluate the question. If still they haven't done it, because I am not doing this revaluation, I am just sending the mails that you are saying. It is not on my hand that I give you the marks, but I have sent the mails. That's why I am telling this to all of you again. If any questions still remain unevaluated or they are not being re-evaluated, please send an email by tomorrow midnight. Then I can get an idea what questions are marked and not marked, and I can again tell them to re-evaluate them. Or I can tell our professor as well that this is the problems that they are facing, so please ask them to re-evaluate them. Do not think that I do not convey your problems to them. I do. Sometimes I do get a reply, sometimes I also don't get a reply, but I am conveying them. So please send a mail again. I will collect all the problems and send them the re-evaluation parts again, because we still have time for re-evaluation. Okay, so as we do not have much time, let me show you the answer. The correct answer was 0.8. Yes, I think one of you just calculated up to F average, because the question that was asked that determine the extent of reaction at which gelation occur. Okay, so it is just gelation means there will be P infinity, that is will be 0. I have stated this multiple times. Okay. So initially you need to calculate F average, that is summation of NiFi divided by summation of Ni. So both the moles were 10. So both glycerol and succinate anhydride was 10 moles. For glycerol, as it has 3 OH groups, so the F value should be 3. And for succinic anhydride, as there are 2 C double bond O, where these OH groups can attack and react with it, so the functionality for succinic anhydride is 2. So your F average value should be 2.5, and once you get the F average, the extent of reaction where gelation will occur, you can get from 2 divided by F average. So if you divide 2 divided by 2.5, you will get 0.8. Okay. This was the question. Actually, F average you have calculated correctly. I think you just missed the determine the extent of reaction at which gelation will occur. I think you just missed that part. How much marks for this question? 2 marks will be for each question in your exam, similar like your assignments. Okay. So this is the next question. Although it's 9, so still let me show you the solution. I am not giving you time again, as it is the last class. Let me quickly show you the solution. Okay, so this question states the equilibrium monomer concentration for radical polymerization of 1,3-butadiene is 80 degrees centigrade. So the temperature is provided, delta H value is given, delta S value is given as well. So you do know delta G is equal to RT ln K, and you also do know delta G is equal to delta H minus T delta S. When you correlate all these things, you will end up with the concentration and the relation with them with delta H and delta S like this. That is, ln of monomer concentration will be delta H minus RT divided by minus delta S by R. So in the question, delta H0 value was provided, delta S0 value was provided, the value of R every one of you know, and the value for temperature is provided as well. So it will be 80 plus 273, that is 353. So all the values are provided in your question. So ln MC will be minus 13.95, and you just need to take a anti-ln. So it will be e to the power minus 13.95. So your final answer will be 8.74 into 10 to the power minus 7. I am pretty sure all of you have answered similar question in your assignments. So I am just quickly. Yes, I will confirm the repeating unit and structural unit part. I think the solution might have some problem. I have just put that in here. I haven't calculated it. I will let you know. Do not worry. Because I have the same confusion as well. Okay. So I think this can be our last question. It states MMA is polymerized by a thermally initiated free radical mechanism at 70 degrees centigrade. The initial monomer and initiator concentrations are given 0.5 molar, 0.001 molar. At this polymerization temperature, the initiator efficiency is 0.75. That is given. All the constant that you require for a thermally initiated free radical mechanism are provided. That is Kd, Kp and Kt. These things are provided. The rate constants are provided for polymerization, transfer and dissociation. Next, the initial monomer and initiator concentration are provided. The initiator efficiency is also provided. You have to calculate the steady state free radical concentration after 1 hour from the start of the reaction, and it is as a power of 10 to the power minus 8. You just need to calculate the value for x. For this as well, you will be needing to remember this particular formula. Again, in this session I am showing you those equations that you will need to remember for exams. So please do remember this particular equation for thermally initiated steady state free radical polymerization reaction. Now in the question, the value for Kd was provided, Kt was provided, F or the initiator efficiency was provided as well. See, the Kd value was 6 into 10 to the power minus 5, Kt was 9 into 10 to the power 7, the initiator efficiency F value is 0.75, that is also provided. Now the only thing that you do not know is the value for I, that is concentration of I, but that you can calculate. You can simply replace it. I equals to I0 into e to the power minus kdt. Now in your question, I0 or initiator concentration is provided. Kd you already know, and it has asked after 1 hour what will be the steady state free radical concentration. Okay, after 1 hour, so the value for small t you also know. So everything now is provided. F is 0.75, kT value are given, I0 value is provided, small t is given as 1 hour. Once you put all of them, you will end up with the monomer concentration or free radical concentration after 1 hour will be 2.0068 into 10 to the power minus 8. So in place of this x, the correct answer should be around 2. Okay. Okay, it is already 9. Let me see what questions. Okay, this will be your final question. Try to solve it, and this will not take much time. That's why I have said. So what is provided here? The initial monomer concentration or initiator concentration is provided. The limiting conversion is 40%. That is also said. You have to increase this limiting conversion to 70%. To do that, by what factor you need to increase the I0 value? Again, I have said it multiple times. You have to remember the formula for P infinity, or at least the factors it depends on. So for a hint, P infinity depends on I0 value only. It does not depend on M0. I have shown you similar problems like that previously as well. So you just need to remember the relation between P infinity and I0. Then you take the ratio and you will be able to get your answer. So keep calculating. Let me show you. So this is your equation for P infinity. So even if you do not remember this whole equation, you do need to remember that minus ln of 1 by P infinity is proportional to I0 to the power half. So it does not depend on M0 at all. So in any condition, if in the question it is asked that M0 is changed, then it will have no impact on the P infinity value. It will only depend on the initiator concentration. So now the question has asked you have to increase the infinity value from 40% to 70%. So that means 0.4 to 0.7 you have to increase. Now I value, the ratio of them, it will simply be the ratio for I at 0.70 divided by I of 0.40. Once you do that, you get the ratio is 2.357, and now you have to remove this half term, so you have to square it. Once you square it, you will end up with a ratio value of 5.55. So by how much factor you have to increase the initiator factor? By almost 5.5 times you have to increase your initiator or I0 value to increase the P infinity to 70%. Yes, you have answered it correctly. It is 5.555. Okay. Oh, fine. How many questions? Only one question left. Then we will discuss this as well. So it states, consider a thermally initiated radical polymerization. 1 second. So it is your thermally initiated radical polymerization. No chain transfer reactions are occurring. It is also said. Okay, no chain transfer is occurring. Termination is occurring via bimolecular reaction between the propagating radicals. At the end of the reaction, the average number of initiator fragments per polymer molecule is 1.65. Calculate the percentage of chains that are terminated by disproportionation reaction. Okay, so this is the question, that how much percentage of chains are terminated by disproportionation reaction. They have provided that how many number of initiator fragments are present in your per polymer molecule. that is sufficient to actually calculate everything. Okay, I already have answers. So yes, they have answered it correctly as well. So simply you do need to remember this final formula where A is the percentage or fraction of chains that are undergoing termination by coupling reaction. There are only two possibilities, either the termination go via coupling, and so if A number of polymers are terminating by coupling, then 1 minus A will be terminating by disproportionation, because we are taking the whole percentage as 1. So if it's A number of the whole fraction as 1, so if A fraction is terminating by coupling, then 1 minus A is terminating by disproportionation. And then how can we relate it to the number of initiator fragments per polymer molecule is by this formula. It is A equals to 2B minus 2 by B. Now you do know that your B value is given as 1.65, and it is also stated, sorry, I think only the B value was given. So if you calculate, your A is 0.78, that means almost 78%. So 78% is terminating by coupling reaction. Now in the question it is asked that how much percentage were terminating by disproportionation. So the correct answer should be 21, because A is for coupling and 1 minus A is for disproportionation. So very careful whether in the question they have asked for coupling or disproportionation percentage. So if coupling has asked, so A will be your direct answer, but if disproportionation has been asked, do not forget to subtract it from 1 and then convert it to percentage, or subtract it from 100%. Okay, fine. Yes, the answer was correct, 21. Fine. Okay, so this was up to this question. So I will again request you all, so whoever was asking for question number 1, this was your question number 1, and the solution is provided as well. So I will again ask you all, please send an email regarding which questions that still require re-evaluation. If it's any question that none of you got marks due to some technical problems, or if you have some personal query, like you have wrote some answers but it was not matching due to some range problem or something, you can write this as well, because only this is up to 22 we will be able to reevaluate the assignments. Okay, after that we can't do anything. So please do write all of those questions that still requires re-evaluation. I will again make a list and send it to them, but as I am saying this again and again, I am just acting as a messenger. It is not on my hands to reevaluate or anything, but I am constantly sending them emails and even called them many times to reevaluate the problems that you are saying. Okay, I just want to clarify that yes, I am mailing them, but still if there are questions, please write to me. I will do that once again, because this is the only time we can do that. So please remember to mail those, and I will there was one question, confusion regarding one question today about DP and XN in the chain stopper question. I will get back to that question tonight, and by tomorrow I will send you or post a message in the group regarding the confusion about degree of polymerization and n value that we are having. Okay, I will do that as well. And again, if any of you have any doubt, you can write to that email before the exam. This is your time. If you have any query regarding any problem, any numerical, feel free to write. This is your only time. And all the very best. I hope you all will get good